Your C code can work and still be a mess. That usually happens when everything is shoved inside main. The input checks, loops, and print statements are all mixed together. At first, that feels fine because the program works. But then you copy the same check somewhere else. Later, you change one copy and forget the other. Now your program has two different versions of the same rule. In security code, that matters because if you validate input, check ports, inspect strings, or parse logs, those checks need to be consistent. That's why functions exist. A function lets you take one job, give it a name, and reuse it without copying the same logic everywhere. So, in this video, we are going to take a look at why functions exist, how data goes into them, how results come back out, and how functions help you turn messy code into structured code. So, let's get to it. Before we look at syntax, let's look at the problem. When you are learning C, it is normal to put everything inside main. Variables, conditions, loops, and print statements all go in one place. Now, for a small program, that's okay. But once the program grows, main can become crowded fast. So let's say we want to check if a username looks valid. For this beginner example, we will use two simple rules. The username must have at least 4 characters and it must not contain spaces. Now here's the first version that we could use. So as you can see here in this code, this part checks the length of the username and this part checks that there is no spaces in the username. Now for one username this is totally fine, but now imagine the same rule is needed in multiple places, like account creation, login, and copying the condition might feel faster, but now the same rule exists in different parts of the program. If the rule changes later, every copy has to change too. Maybe usernames should now be at least 6 characters instead of 4. You update one copy, but forget another, and now your program behaves inconsistently. That's how copied logic becomes a problem. And in cybersecurity, inconsistent validation can become dangerous. So instead of leaving the username rule directly inside main, we can move it into one named function, like in this example. Now the validation logic lives inside is valid name, and this line becomes much easier to understand because the program is basically asking, is this username valid? That's the first big reason functions matter. They let you take important logic, give it a name, and reuse it. So, if the rule changes later, you update the function once instead of hunting through the whole program. Now let's break down what a function actually is. So, a function is a named block of code that performs one specific job. Here's the function again. There are 4 main parts. So, the first is the return type. And this tells C what kind of answer the function gives back. Here, int means the function returns a whole number. In this example, 1 means valid and 0 means invalid. The second part is the function name, and this is the name we use when we call the function. Then the third part is the parameter, and a parameter is data that goes into the function. So here the function receives a string. The word const means the function should read the string but not modify it. And fourth, we have the body, and the body is where the work happens. So the basic idea is data goes in, the function does the job, and the result comes back. Now let's say that the user inserts the word admin. Then the program will return 1 because the word admin has more than 4 characters and has no spaces. However, if the user inserts guest user, then the program returns 0 because the username contains a space. That's the basic shape of a function, a named job with input, logic, and sometimes output. Now, a function doesn't run just because you wrote it. It only runs when something calls it. In this program, the call happens here, and when the program reaches this part, it sends the value stored in username into the function. Now, inside the function, that value is received here. This is where 2 words matter, argument and parameter. The argument is the actual value you pass into the function, and the parameter is the variable that receives it. Here is a simple port example. In this function, port is the parameter. Now look at this call. Here 22 is the argument. So the value 22 goes into port, and the function checks whether it's in the valid range. Now, passing data into a function is only half of the story, and sometimes we also need a result back. That's what return is for. A function can receive data, do some work, and return a value that the rest of the program can use. Here is an example. So this function checks whether a port is one that security people often review. So if you don't know, port 22 is SSH, 23 is Telnet, 445 is SMB, 3389 is RDP, and 5985 is WinRM. Now, if you have solved HTTP boxes, you know that these ports appear a lot in those boxes. Now, these ports are not automatically malicious, but they often matter because they are related to remote access, administration, or lateral movement. So this function asks one simple question, which is this a port we may want to review? So if yes, it returns 1, and if no, it returns 0. Now, the rest of the program can use that answer. So for example, if the user inserts 3389, then the program will print port 3389 may need review because it's inside of the list. Now let's put everything together. We are going to build a simple port review program. Now be aware that this isn't a real scanner. It doesn't connect to anything. It only processes a list of port numbers so we can focus on functions. Here is the massive version with everything inside main. So this program works, but main is doing too much. It stores the ports, loops through them, validates each port, checks whether it needs review, and prints the result. Those are separate jobs, so let's turn them into functions. So let's insert the first function that checks whether a port is valid or not. That function is this one. So if it's valid, it returns 1, and if it's not, it returns 0. Now let's add the function that checks whether a port needs review or not, and that function is this one here. Now remember guys, these functions we already saw in this video earlier. Now let's add a function that handles one port, so this one here. This function receives one port, checks it, and prints the correct result. If the port is invalid, it prints the invalid message and stops early. Finally, we can create a function that processes the whole list, and that is this one here. Now this function receives the array and its size. Then it loops through the array and sends each port to print port result. Now there's only one thing left to do, which is insert our main. So let's do it. And finally, this is our main. Now main is much easier to read. It creates the data, calculates the size, and calls review ports. That's the real power of functions. They make the structure easier to understand. But functions are not only useful for writing code, they also help you read code. When a program is split into clear functions, you can follow the flow without understanding everything immediately. Look at the main again. Even before reading the helper functions, you understand the big picture. The program creates a list of ports and reviews them. Now you can follow the calls like a map. So, for example, main starts the program. Review ports loops through the list. Print port result handles one port. Is common risk port checks whether the port needs attention. And then is valid port checks the range. That's much easier to read than one giant block of logic. That's why structured code matters, because it gives you a map. And that's it guys. If this helped you in any way, give it a thumbs up and subscribe to this channel for more content like this. Thank you for watching. See you next time. Stay curious and stay safe. Bye bye.